Lecture 5-2 Igneous Rocks. Remember from the last lecture video we talked about the three main types of rocks: igneous, metamorphic, and sedimentary. Igneous rocks are formed from a molten state. So that means that they're formed from either magma or lava. And then they solidify and form the rock. They make up most of the crust of the earth. They're usually very tough because of this. Magma is an intrusive rock, which means it forms besides the earth. So all intrusive rocks are formed from magma. They typically have larger crystals due to slower formation, and they can tend to be denser, at least more solid or smoother than the other kind, the extrusive rocks. Extrusive rocks form above the surface of the earth, typically from lava from a volcanic eruption. So for volcanoes, they have smaller crystals due to faster formation because they come in contact with air or water. They also tend to have vesicles. And vesicles are small openings in the rock which form because gases escaped as the rock cooled. So as these gases escape, they leave these little openings behind. So think about volcanic rock, lava flowing to the water, lava cooling very quickly and forming. Gases are escaping, leaving these little openings, and the rock solidifies, leaving these little openings making the rock look very porous. And because of this, extrusive rocks tend to be lower in density, a little rougher on the outside, a little weaker of a type of rock. Granite and basalt are two main types of igneous rocks. Now, igneous rocks are also identified by their composition, what makes them up. And we have four main categories for that: felsic, mafic, intermediate, and ultramafic. And these kind of depend on the silica content. Silica is, of course, silicon and oxygen combined together, forms most of the materials in the surface of the earth. A low level will create a darker rock, and so mafic tends to have low level silica, while a higher level of silica means a lighter color rock. So felsic, which is a light colored, low density rock made from minerals such as quartz and feldspar. Mafic is dark and high density, so this color difference oftentimes is because of the amount of silica it contains. So felsic means it has high silica typically, and then mafic has low silica. Intermediate is between felsic and mafic, and ultramafic contains more than 90% mafic minerals, so very few light felsic minerals, and so it's a very dark rock. So this doesn't always, now this is why I wrote the word usually, it's not always true. There are certain types of rocks that their color may throw you off, but most of the rocks, if it's light colored, it's going to be high silica content, dark colored, low silica content. Now, what you need to do after you give these directions is stop the video. You're going to go do the igneous lab, then come back to video to check your results. It's important that you go into the lab without the answers. Try to come up with them yourselves so you can see the differences between the rocks, because you're not going to have to memorize rocks, although there are some that I'm going to expect you to know. I don't want you to know like hundreds of rocks. I want you to be able to identify them by looking at the different properties. You should be able to, at the end of this unit, look at any rock and tell me if it's igneous, sedimentary, or metamorphic, and why. So stop the video, do the lab. I mean it. Stop the video, go to the lab. If you're still watching the video, then either you're not listening to the directions or you already done the lab. Good job. And now you come back, check your answers. So here are the answers to the lab, to the rocks that we have in the classroom. Their silica content, their grain, which is the hard one to see, and then if it's intrusive or extrusive. So the X over here means extrusive, and the N means intrusive. Just don't feel like writing in the X. The one rock they said that is kind of like violates one of the rules is obsidian. It has high silica content, but it's very light. It's very dark colored. Obsidian is also an extrusive rock formed from volcanic eruption. And so because of that, it looks different. Even though pumice and obsidian can both be formed from volcanic eruptions on the Earth's surface, because they're made of different materials and they form differently in specific ways, they look very different. So let's look at some of these rocks. Granite and basalt. Granite on the left here. Here's granite, and here's basalt. Granite forms inside the Earth, so it's a denser rock than basalt. It has larger crystals. Basalt here, you can see these little openings here are those vesicles I talked about. If you see them, they are a clear sign that's an extrusive rock. We actually call this vesicular basalt. We have good samples of that in the classroom. Obsidian here on the left, pumice on the right. Pumice is actually a rock that can float, and it gets a foamy consistency because of all the gases that escape when it formed. And pumice is actually a mixture of ash, glass dust, and gas, whereas pumice forms very, very quickly, and so no crystals can form, and it almost looks glassy. But these two are both formed from volcanic eruptions. Now, if you go to Hawaii or some islands which are formed from volcanoes, you're going to see black sand. And that black sand is formed from obsidian broken down into sediments over time.